Okay, class, this is stoichiometry right here. Remember, we're doing measuring the amounts of chemicals. And so we can read our question. It says oxygen gas can be produced by decomposing potassium chlorate using the reaction below. There's a given reaction for us. And in that reaction, we have 2 moles of potassium chlorate producing 2 moles of potassium chloride and 3 moles of oxygen. And then we're given a mass, which is going to be where we start. So we're given a question similar to what you'll see on quizzes and tests. It says if, right here, 138.6 grams of potassium chlorate is heated and decomposes completely, what mass of oxygen is produced? So we're starting with a mass of potassium chlorate. And the question is asking, with this much of this, how much of this will be made? Okay, so we always start with what is given. And in this situation, we have 138.6 grams given to us. And we're going to convert that to moles, because moles is how we go from one unit to another. So we're going to start with grams of potassium chlorate. All right, start with that. And we're going to convert. And so if we have grams, anytime we go to moles, we want to put that on the top of our conversion. So the unit will change from grams to moles. And to do that, we have to cancel the unit that we were given to start with. So we have to know how many grams are in 1 mole of this. And that's where we use our periodic table. So we're going to have to use this and find potassium first, which is 39. So there's 39 grams in potassium. And then over here, there's chlorine, and that's 35 plus 35. And then we have oxygen, which is 15.9, so 16. And there is 3 of those. So when I calculate that, I end up with, this is actually 48 grams. So 48 plus 35, which is going to be 70, and then 5 and 8 is 13. So 83. And then we're adding 9 to 3, so that would be 92, and then 30. So that would be 122. So there's going to be 122 grams in potassium chlorate. And we would end up dividing this number by this number in the future of our problem. But before we do that, we're going to move to what's going to happen next, because we're not finished. We now have to convert from one compound to another. And that's where we use the mole ratio, and that comes from our reaction. So we're going to put what we have on the bottom always, because that's what we're canceling out. That's not what the question asked for. The question asked for mass of oxygen, and we have moles of potassium chlorate. So we put moles on the bottom of this, and we want moles. They stay the same, but instead of this compound, we want to know about oxygen. So we're going to put moles of O2. And we're going to look at our reaction to find out what that ratio is. Well, for every 2 moles of this, I have 3 moles of this. Okay? So now we've gotten ourselves up to our mole ratio, right? And then we can move to our next step. We have moles of O2. The question asks for mass, which is in grams. So we're going to cancel out moles of O2. And now that we have the right compound, we can put grams of O2 up here. And we will now use our periodic table again. Find oxygen. Here is 16, but there's 2 of them. So 16 plus 16 equals 32. So we have 32 grams per 1 mole equals. And then on our next video, I'm going to show you how we calculate this. So this sets up our problem here step by step, one at a time. I canceled out grams to get to moles. I canceled out moles of one compound, potassium chlorate, to get moles of oxygen. That's using that mole ratio. And then I canceled out moles of oxygen to get to grams of oxygen, which is what this question is asking for. So this is our process called stoichiometry.